Okay, welcome to part 2 of section 7.1. Excuse me. Sorry about the splice job getting here. I just had an error on this page, a really simple page to be honest, and I just wanted to redo the video. So this I've turned section 7.1 into three sections with a little splicing. The first section talks about this fundamental theorem of calculus. We're going to come right back to that, but it says solve the initial value problem. So what we would like to do is find an antiderivative of sine of x squared. We would say, well, it must start as cosine of x squared, and if it's the derivative of cosine of x squared would involve a negative, so we have opposite of, and the derivative of now negative cosine of x squared is positive sine of x squared, good, but times 2x, bad. So that doesn't do it. So we don't have a very convenient way at this time to do that. So it says your answer will contain a definite integral using the fundamental theorem of calculus. So let's go back. Fundamental theorem of calculus says if f is an integral, we can turn that into, see, if I take the derivative of both sides, I get df. The derivative of the integral basically cancel one another, but this is f of t, and how do we get that back into a function, because f is a function of x? Well, when we go through the integration process, we're going to put x into this f of t. So that's the process we're going to go through. It's really, really simple. I don't think I probably did justice to it, how simple it is. So what we're going to do is we're going to say the initial value, solve the initial value problem. Y equals, I just integrated that. Oh, that's pretty nice. So we get y, plain old y, antiderivative of the derivative, y, gives us the integral of sine, there's my introduction of t squared dt. Now, here's the deal. This says when x equals 1. Now, eventually I'm going to put x into this. That's what's going to give me the sine of x squared. Now, I can have any constraint down here I want at any given time, and I'm going to choose 1 down here because when x is 1, when x up here is 1, this now is the integral from 1 to 1, and we know well that the integral from 1 to 1, that's just big 0. And then that would be like our plus c. Okay, so y is 5 when x is 1, and x is 1 here, excuse me, x is 1, that's 0 now, so I get c is 5, so I just end up with this. Y equals integral from 1 to x sine of t squared dt plus 5. Okay, and we can probably just go directly from here to here. Hopefully we understand the process of what's going on there. Setting this x to 1 basically lets me eliminate this big 0 and find out what c is. So let's take a look at this second problem. It's going to be a short video. This says our derivative of this, might as well say dy dx, is this. Find the antiderivative. Well, maybe I could just find the antiderivative of this old school. What's the derivative? The derivative of e to the cosine of x is e to the cosine of x, but times sine of x, and that's the problem. So we're going to say integral of the derivative gets us back to the original function, y, or we probably should say, truthfully, f of x is integral. We're going to run that through x, so that would be e cosine of t. That way, when I integrate and put x in here, we're back to here, dt. This is saying when x is 2, y, or f of x, is 9. So if I start 2, that makes this, when x is 2, if I start at 2, that makes all of this have no width. It goes from 2 to 2, therefore it's 0. So that makes when x is 2, f of x is 9. When x is 2, this is 0, therefore c is 9. So my final answer is f of x equals integral 2 to x e to the cosine t dt plus 9. And you can just see, we can just piece those in here, but hopefully there's some understanding that's going along with that. I hope that helps. There is a part 3 that follows this. Thanks for checking it out.